Welcome to this lecture. In this video, we'll discuss some important network commands which, as an administrator, network administrator, either you can configure the network through those commands or can know the things and know more about your network, or either in any troubleshooting situation, uh, these all commands would be quite handy. So we'll start with the first command, which allow us in finding out how many interfaces are associated with our system and what is the configuration of those interfaces. And through the same command, not only we can know the information about those interfaces, we can manipulate that information, we can change that information. So that command is interface configuration, if configuration. So after running this command, system will tell you the number of interfaces, those which are running. It will tell each and everything. Anything which is starting with E corresponds to Ethernet interface. So this is not up, so you can see the received. So it will give you some basic information. What is the IP address? What is the MAC address of the interface? What is the maximum transmission unit? Means as a packet, as a complete frame, how big that packet could be which can pass through that interface. So that is called MTU, maximum transmission unit, MTU. So all these things we can vary also, we can change also. So using the same command, so if you will go and figure out and manual command man if configuration, it comes with several options. So here you can see it comes with several options. You can change the interface in Prometheus mode. You can configure the interface in the way you want. So there are several configuration possible through if configuration command. And the next, so here I'm using the wireless interface, and here you can see that this is the internet address. This is the network mask. These three details are important, and this is the broadcast or that edge router address. This is the broadcast address or the gateway address. So these three things are important for communication. So when you want to up a network, up an interface, so that interface should be aware about, your system should be aware about these three information. That interface should have an IP address. It should know its network mask, which allow us in identify the network which it is part of. And then the third one is the gateway address, that if anything comes and it doesn't know where it has to uh, reroute it, so finally under that situation it will reroute it to the broadcast address, or that is called the gateway address. And then IP version 6 address of this interface is this, and this is the MAC address or the physical address. Every interface comes along with its physical address. And here till now it has received these many packets. In bytes it is this, and there is no error in receiving, there is no drop, there is no overrun, and the transmission packets are these in numbers. It has transmitted these many packets so far. Since the time it has started, the interface is up. Then the next command is if you want to check the connectivity. So suppose as an administrator, there's a problem that from one device to another device, there is some situation, some problem is there. So the very first command which generally administrators use, they try to ping from one device to another device that there is a connectivity problem. So you can break down the ping also. So in a way that if there is a connectivity issue from A to B, so you will break it down, and in between whatever comes, you will try to check the connectivity till them. If it is possible, then in a way you can narrow down the problem, that where exactly the problem is. Suppose from A to B the problem is there, but in between comes the C. From A to C there is no issue, so that means from C to B there is some issue. Then once again you will go on to the C system, and from C to B you will find the connectivity issue. From C to B there is an intermediate node D, so you will check the connectivity from C to D. If there is no issue, then from D to B the problem is there. So in this way you can narrow down the problem through ping. So here we will check the connectivity, that from my device whether I will be able to ping. You can give two inputs to this command, two arguments. One argument is the domain name, means that site name itself you can give, that web address you can give, or you can give the IP address. So suppose we are giving one IP address 4.2, it's a global DNS IP address I am giving. So there is a connectivity. So we are coming out. If you will run this command without an option C, that is count, then it will keep on pinging. So ping use the command, the control command, that is ICMP, Internet Control Message Protocol. So it will keep on sending and receiving. It's just a request and reply protocol from the device where we are pinging. So this is ICMP, send and receive. So it will give you the stats. So we have transmitted 9 packets, 9 being received, so there is 0 packet loss, and it has taken this much time in total in sending and receiving 9 packets. And this is called the reverse transmission time, or in a way response transmission time. Reverse transmission time is better to say, because what RTT is, that when you will send a packet, request packet, it will reach the destination. It will reach 4.2.2. That global DNS, and then global DNS will respond. So in one request and response, so what time in occurred? So that in occurred time in one to and fro of the packet is called reverse transmission time. So it's stats in terms of its minimum, average, maximum, and mean deviation. So it will give you this. So if you want to ping for specific number of time, we have to use this option. Then this time we are pinging manipal.edu. So 5 times, 5 packets transmitted, 5 received, there is 0 packet loss, and it has taken this much time, 4000 millisecond. And this is the case regarding RTT time. So minimum it has taken 80, for one of the packet it has taken only 80 milliseconds in sending and receiving it. And max average is this, maximum is this, and this is the mean deviation. So this is about the connectivity. The full form of this ping is packet internet dropper. So P for packet, IN for internet, and G for gropper. So that is the expansion of ping. Then the next one is that from the location A to the location B, if on that troubleshooter wants to know the path, that what comes in between. So how we can find out the path from source to destination, in between what nodes comes. So we will use the command trace route, and then we will give, suppose, till so it has taken 16 intermediate nodes. the first one, that first router, whatever the router, whoever is maintaining it, they're not willing to reveal their information. So it is private information. They are not wanting to make it public. So there, in that situation, you will see these strict marks, and they are willing to share their information. So it has received at this time. So these are all the information. So these many IPs comes in between. So this will give you a clue that where exactly your packet is going from your location till the final location. So that is trace route. It has also several options you can check through. Manual of trace route. So many options are there. These many options. And then comes so this is regarding finding out to the intermediate nodes which comes along the path towards destination, that is trace route. We will understand all these protocol, ping protocol, trace route protocol, that how they are designed. So these are the application layer protocol, but underneath what goes into their design, which protocol they are using, how they are using, what is the architecture of those, what is the format of those packets which they are sharing, everything will, and what is the concept behind trace route, how does it work. So all these things we'll understand. Then the next one is that if you want to find out the routing table which your system is maintaining, and there is a network statistics command. So it will allow you several other things, but here I will show you that how through network stat you can find out to the routing table which this system is maintaining. So if you will run the same command on any router, so what router is maintaining, it will come. So here what my system is maintaining, so this is the routing table. So if this is the routing table, I have already discussed with you. What is routing or forwarding table is that based on the destination address, the device will reroute your packet towards certain interface. So here this is the destination address. So if the destination address is this is the default gateway, it will send it toward this. Then this is the mask of that. So through mask you can figure out what is the network address and all other. So it will tell you the interface over which it will send. I am here using only the wireless interface. So anything which I am sending from here, my routing table is sending it to uh, my interface, that is wireless interface, and that is the address. This is the address of uh, the destination. So this is the only destination. So my system is only maintaining minimum information, because whatever I am generating, it has to just reroute it on my interface. So this is regarding, so same command if you will execute on any router, there are n number of interfaces. Based on destination, it will reroute, because first initially the device will run an algorithm, routing algorithm. Based on that, it will generate the forwarding table, that is, and so if the destination is so and so, it will reroute it on this interface. So all that information. So this is the format of the forwarding table. There are several other options available with NetStat as well. These are all the options. Then the next one is that if you want to find out certain DNS information, that if there is DNS is domain name service, so we are using the name, and our system or the internet will use the IP addresses. So there are n number of servers all across the world which maintains this mapping. And initially, whenever we write any host address, any address where we want to connect with, then first thing the network will do, it will call the DNS, and DNS will return back the IP information, and then you will start making the packets or the segment at the transport layer, then the network layer. So from there, from DNS, we get that mapping information. So if that information we are interested in, then there is a dig command that is called domain information graph grouper. Dig, dig, and to suppose we are interested in manipal.edu. So this is sort of a DNS packet format which being shared. So there is a single query. We have asked for this query that what is the corresponding IP address for www.manipal.edu, and it has given us 4 answers. It might be possible that they are maintaining the same website and they are serving all across the world through several servers. So these are all the answer sections. So these are this is IP address, this is IP address, this is IP address corresponding to the same manipal.edu. How they are maintaining it, though the name is same, but they have also canonical name that is called alias. So some other name also maintained, because only one IP address can have a single name, otherwise there will be a problem. But on top view, on a top level, it maintains, because all across the world you require to maintain a same name, but you are serving the world from several servers, so those servers where you are maintaining must have different name, so that internet can understand that. So that's why in answer section 4 answers are there. So that is regarding DNS information you can figure out. Regarding any domain name. Then there is one more command, ns lookup. It also gives you DNS information. Ns lookup, and to the same www.google.com, not Google, Manipal, we will check, manipal.edu. So same addresses but in different format. It is giving less information. It is giving more or less the same packet format which being shared from source to destination and then received from the DNS server. The next one is so ns lookup and dig, both commands if you will use, you will get a domain name server information. If you will write if you will give a query, you will get an answer in the response packet. Suppose there is one more command for finding out the routing table. So every system maintains a route. So manually, if you want to manipulate or change that routing table, then there is a root command. Or in general also, you can use the root command for finding out the kernel IP routing table, the system which I'm maintaining. So here you can add, delete also. So this command allows you to do that, I think, but with some root privilege. You should have root privilege for adding and deleting it. That you can check, but it's better not to manipulate anything until and unless you are aware that where you have to route your packet. Then comes host name. So host www.google.com. So right now, if you have to just check that what is the IP address, the IP address of a server where Google is maintaining its website, which is near to me, or so you can use host. So it will convert IP address to host and vice versa also. If you will give the IP address, it will give you the host address, the domain address, the name address it will give you. So here we have given www.google.com, so as this address. If we will give www.manipal.edu, so has these many addresses. If suppose I will give host 13.33.144.115. So here you can see, though it belongs to manipal.edu, but here you can see this address, it's different. Because there it is, this Manipal, this website is maintained on this IP address, but with this name. Then there is one protocol, address resolution protocol, ARP protocol, and this ARP protocol is address resolution protocol, which converts the IP address into physical address or the MAC address, or vice versa, from MAC address to IP address. That is called reverse ARP, RARP. So ARP protocol will just convert the network address to physical address, that is IP address to MAC address. So if we have to check, so for that purpose, so your system maintains ARP table. So if we have to just check that ARP table, so this is the ARP table which my system is maintaining. If you will run this over a switch, there will be multiple entries. All that we will check through simulator GNS3. So that is ARP. This much is enough for now. Then the next protocol, next one, sorry. Next protocol is for wireless configuration. So if for IW configuration, for wireless configuration, so if you want to see the wireless configuration, there is no wireless extension because it is Ethernet port, then here it is. So if you are interested in the information regarding wireless interface which you are using, so there are several extensions for this IW configuration. So several extensions comes along with it. Options are available that you can check through manual command. You can configure also. You can configure, so all the information which you're getting here, you can configure many of the information through the same command, but you should have the right or root privilege for doing that. Now if you want to check your name, host name, what is your name? So this is the name of my device. Through host name you can even change also your name. And there is one more command, who is www.manipal.edu no match, who is google.com. So it is not showing who. There is some database failure. The registry database contain only. So this is also redundant already, means it will also show you the yeah. So it will show you the domain related information. So who is the registrant, who has registered it. So all these information, and what is the name of those servers which they are maintaining. So all these informations regarding the domain. So you can figure out using this command who is. So if we will use who is google.com, so here regarding them the information is there. So if you are interested in knowing more about who is the registrant and what is their address, all these informations, then okay, so that's it. In the next lecture we'll come up with the GNS itself.